Now write on next property. Next property of alcohols, property number 4, oxidation. Oxidation. Now, first write down the list of oxidizing agent which can be used for the oxidation of alcohols. A, KMnO4 oblique H2SO4. Oblique means and, right? This is called acidified potassium permanganate. Please make the list and write in the same order in which I am writing, right? Second, B, K2Cr2O7 sulfuric acid. This is acidified potassium dichromate. Acidified potassium dichromate. Third, that is C, we can use anhydrous CrO3, anhydrous chromium trioxide. Fourth, D, we can use hot copper, copper at 573 Kelvin. E, last oxidizing agent is PCC plus CH2Cl2. What is PCC? I'll tell you. PCC plus CH2Cl2. In this case, CH2Cl2 is solvent. Now, what is PCC? PCC is pyridinium. I'll dictate. PCC is pyridinium, pyridinium, pyridinium chlorochromate. Pyridinium chlorochromate. Formula is C5H5NH plus CrO3Cl minus. C5H5NH plus, positive charge at nitrogen, CrO3Cl minus. Further add, it is prepared, PCC is prepared by mixing pyridine plus HCl plus CrO3. So these are 5 oxidizing agents. How do we use them? Write down next paragraph. Product of oxidation of an alcohol depends on the class of alcohol oxidized and the oxidizing agent used. It means what will be the product obtained on oxidation, that will depend on whether we are oxidizing a primary or secondary or tertiary alcohol. Number 2, it will depend on which oxidizing agent is being used. So we'll take it up in 3 different parts. Write down A part. Oxidation of primary alcohols. Oxidation of primary alcohols. Rather than giving dictating in words, I'm drawing, please copy it. RCH2OH. This is primary alcohol. Above the arrow, A or B. It means if we use oxidizing agent A or B, then product obtained is a carboxylic acid. Product obtained is a carboxylic acid. If we use B or C or D, sorry, if we use C or D or E, I'll repeat, if we use C or D or E, last three, then product obtained is an aldehyde. And if we further use E, then aldehyde will further get oxidized to give a carboxylic acid. I'll repeat, understand this. A and B, remember, A and B are strong oxidizing agents. They will directly convert primary alcohol into carboxylic acid. Remaining three oxidizing agents will convert primary alcohol into an aldehyde. But out of these three, if we further react aldehyde with E, what was E? C. This is my mistake, not E, C. So if we further react aldehyde with anhydrous CrO3, then final product obtained will be a carboxylic acid. Now, B part. Oxidation of a secondary alcohol. Oxidation of a secondary alcohol. Write the equation again. RCHOH R dash. This is secondary alcohol. In this case, use any oxidizing agent, product will be a ketone. So we use A or B or C or D or E. Product is a ketone. See, when we oxidize primary alcohol by using last three oxidizing agents, product was an aldehyde. Now, there is some similarity here. In case of primary alcohol, product was aldehyde, and in case of secondary alcohol, product is a ketone. Now, in both these reactions, there is removal of hydrogen molecule H2. How is this hydrogen molecule eliminated? That I'll tell you. Write on next paragraph. Oxidation of a primary alcohol. Oxidation of a primary alcohol to give aldehyde and oxidation of a ketone, oxidation of a secondary alcohol to give a ketone involves breaking of OH and CH bonds, involves breaking of OH and CH bonds and formation of C double bond O as shown below. As shown below. Now please copy from the board. This is the general representation of a primary or secondary alcohol. How come? Right now you can see this appears to be a secondary alcohol because there are two alkyl chains. But remember, if one of these two alkyl chains is hydrogen, then it will be a primary alcohol. It means whether this is a primary alcohol or secondary alcohol, this part will be common. This part will be common. Now, in this part, there will be breaking of two bonds. Oxygen-hydrogen bond will be broken. Carbon-hydrogen bond will be broken. At the same time, a double bond between carbon and oxygen will be formed. This I am representing in the form of homolytic cleavage. See, this is homolytic cleavage. This is homolytic cleavage. H free radical and H free radical will combine to form H2 molecule, right? Two hydrogen free radicals will be formed, 1 plus 1. They will combine to give H2 molecule. This free electron and this free electron, they will join together and lead to the formation of a pi bond. So this is the formation of C double bond O. So whether this is a primary alcohol or secondary alcohol, it's nothing but removal of hydrogen. And removal of hydrogen is nothing but dehydrogenation. So write down. Thus, this reaction is called dehydrogenation of primary and secondary alcohols. Dehydrogenation of primary and secondary alcohols. Now coming to C part. C part. Oxidation of tertiary alcohols. Oxidation of tertiary alcohols. Madam, tertiary alcohols do not undergo oxidation. Tertiary alcohols do not undergo oxidation due to the absence of hydrogen atom at alpha carbon atom. At alpha carbon atom. Look here. This is alpha carbon which carries OH group. And this alpha carbon does not carry any hydrogen. This is the reason tertiary alcohols do not undergo oxidation. But they react with some of these reagents in a different manner. What is that? Now write down. Next paragraph. Tertiary alcohols do not react with PCC and CrO3. It means they do not react with C and E. They react with A, B, and D. Next paragraph. With hot copper was D. With hot copper, tertiary alcohols give an alkene according to Sazov rule. Give an alkene according to Sazov rule. For example, this is tertiary alcohol. When this is heated with copper, this is copper at 573 Kelvin. There will be loss of a molecule of water. There's nothing but beta elimination. So hydrogen from beta carbon and OH from here will lead to formation of alkene according to Sazov rule. That is, more symmetrical alkene will be formed plus water. So out of 5 oxidizing agents, first of all, oxidation does not take place. 2 of them do not react with tertiary alcohol at all. This is the third one, hot copper, which will lead to formation of an alkene. Now we are left with first 2 oxidizing agents. How do they attack a tertiary alcohol? Right on, next paragraph. With A and B, a tertiary alcohol first undergoes dehydration to give an alkene according to Sizov rule, which on further oxidation gives final products, more than one product, right? Final products according to following steps. So when we use A and B, tertiary alcohol will first change into an alkene according to Sizov rule, and this alkene will further be attacked by A and B, and further oxidation of alkene will give final products. How do we write these final products? I'm giving you 4 steps. Follow these 4 steps and you'll get correct products of oxidation of alkene. These, in fact, you have studied in 11th standard also. Right on. Number 1, break C double bond C. You just keep on writing. When I give you example, then only you will be able to understand. Number 1, break C double bond C. It means this will split into 2 parts. Number 2, attach one oxygen atom through a double bond to both the carbon atoms, between which double bond is broken. Number 3, replace all hydrogen atoms attached to carbon atoms of C double bond C by OH groups. Last step, number 4, if more than one OH group is attached to the same carbon, it loses water to give a stable product. For example, I'm taking 2 examples and I'll tell you what you have written in these steps. Please keep on writing. This is tertiary butyl alcohol. With A or B, first of all, tertiary alcohol will change into an alkene. Now you can form a double bond between any 2 carbon atoms because this is symmetrical. This will lead to the formation of alkene. This alkene will further get oxidized with A or B. So further oxidation. Now, how do we write products of further oxidation of alkene? For that, I have dictated you 4 steps. Now, just concentrate on board. You can copy it down later. Try to understand how do we apply these 4 steps. Step 1, break carbon-carbon double bond. When I break two double bond, these are 2 parts obtained. Step 2, attach oxygen through a double bond to both the carbon atoms where double bond is broken. Double bond is broken between these 2 carbon atoms. Attach oxygen through a double bond. Step 3, all hydrogen atoms attached to these 2 carbon atoms which had a double bond between them, replace all those hydrogen atoms by OH groups. No hydrogen, no OH group. 2 hydrogen atoms will be replaced by 2 OH groups. If you remember, I told you earlier, if there is one OH on a carbon, it is stable, but if there are more than one OH groups on the same carbon, it will be unstable. It will lose water and give the final stable product. So this will lose a molecule of water. After losing water, this will change into carbon dioxide. So you can see products are, this is propanone, acetone, carbon dioxide, and water. Please copy this. Then I'll give you a second example. Done? Now, second example. This is again a tertiary alcohol, tertiary pentyl alcohol with A or B will get an alkene, but remember, alkene this time will be written on the basis of a Sazov rule. More symmetrical alkene will be formed. This is the alkene obtained. Now, this alkene will further get oxidized according to those 4 steps. I'll complete valency by using hydrogen atoms. Break double bond. Step 2, attach oxygen, double bond O, double bond O. Step 3, replace hydrogen atoms by OH. No hydrogen, no OH, one hydrogen replaced by one OH. Step 4 will not be used because there is only one OH on one carbon atom. So final products are, this is propanone, that is acetone, and the second product is ethanoic acid, acetic acid. So these are 2 products formed. Please quickly copy this one. So with this, we finish first category of reactions, that is reactions involving OH bond cleavage. That category we have finished. Now write down capital B part. B part. Reactions involving, right, like this, CO bond cleavage. CO bond cleavage. Now, in this category, write down first chemical property. Reaction with phosphorus halides. Reaction with phosphorus halides. We already done this reaction. Within brackets, write down C preparation of RX. C preparation of alkyl halides. That is over. Number 2. Reaction with thionyl chloride. Reaction with thionyl chloride, SOCl2. For this also write down the same C preparation of alkyl halides. Third property, reaction with HX. Reaction with HX. See, although we have already done this reaction in preparation of alkyl halides, but we have to take up more details about this reaction. So first of all, within brackets, write down C preparation of alkyl halides. C preparation of alkyl halides. Now, I'm writing one equation. Do not copy it. Just look at the board. Do you remember name of this reaction?
Sir, Lucas reagent.
That Lucas reagent I did not tell you. I'm going to tell you now. Do you remember this reaction when I taught you preparation of alkyl halides? This is Grove's method. You should go through my notes. This is Grove's method for the preparation of chloroalkanes. But remember, in Grove's method, we use HCl gas. But now I'm going to use concentrated solution of HCl. This concentrated solution of HCl and anhydrous zinc chloride, this mixture is called Lucas reagent. Don't write anything, just understand. So when alcohol is reacted with Lucas reagent, what is Lucas reagent? Concentrated solution of HCl and anhydrous zinc chloride. Product will be same as we obtain in case of Grove's method. Chloroalkane is obtained. Now, if you think of properties, physical properties of alkyl halides, there I told you, alkyl halides are insoluble in water. So this alkyl halide produced, this will be insoluble in water. Now, which water we are talking about? We are talking about water which is present in concentrated solution of HCl. Plus, a small quantity of water will be produced during the reaction also. But this chloroalkane produced will not dissolve in it. It will remain suspended in the test tube in the form of very, very small insoluble particles. Due to this, contents of the test tube will become translucent, right? Earlier reaction mixture is transparent, but due to the formation of this product, contents of the test tube will become translucent. And this translucency is called turbidity. Turbidity. It means during this reaction, turbidity will appear. Why? Because chloroalkane produced will be insoluble in water. Now, reactivity order of alcohols is tertiary more reactive than secondary, secondary more reactive than primary. Since tertiary alcohol reacts fastest, it means this turbidity will appear immediately if the alcohol is tertiary. If the alcohol is secondary, reaction will be a bit slow, due to which it will take 2 to 5 minutes for this turbidity to appear. But in case it is a primary alcohol, reaction will be very slow. It means turbidity will appear after a very long time. So this reaction can be used to distinguish between primary, secondary, and tertiary alcohols, and this is called Lucas reagent test. So I've explained everything. Now I'm dictating you. Adam, consider the reaction. Consider the reaction of an alcohol with concentrated HCl and anhydrous ZnCl2 zinc chloride, which is called Lucas reagent. LUCA, Lucas reagent. Now write down the equation. ROH plus HCl concentrated and add a zinc chloride. Label this mixture is called a Lucas reagent. Label that. Gives chloroalkane plus water. Yes, further item. Since RCl, since chloroalkane formed is insoluble in water, its formation leads to the appearance of turbidity. 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 Since reactivity order of alcohols is tertiary more than secondary more than primary, turbidity appears immediately if the alcohol is tertiary, it appears after 2 to 5 minutes if the alcohol is secondary and turbidity appears after a very long time if the alcohol is primary. This reaction can be used to distinguish between primary, secondary, and tertiary alcohols, which is called Lucas reagent test. Next property number 4. Reaction with acidic ammonium nitrate. I'll repeat. Reaction with acidic ammonium nitrate. This is called CAN. CAN. Pattern. Alcohols react with CAN to give red or pink colored product. Red or pink colored product. Write the equation.
Sir,
Red or pink.
sir, Sir, is violet also formed like in the reaction?
Violet is for phenols in with FeCl3.
Okay, sir.
That is the reaction of phenol. So two molecules of alcohol plus can. Formula of can is NH4 twice CeNO3 6. This compound is can. This is a coordination compound. Nomenclature of coordination compounds we'll study in one of the chapters later in 12th standard. This will lead to the formation of CeNO3 4 times ROH twice. Product is again a coordination compound, and this product is red or pink in color, plus two molecules of ammonium nitrate. Again, product is a colored product. Naturally, this reaction can be used as a distinguishing test. Radam, below this only you can write distinguishing test for alcohols. This reaction is distinguishing test for alcohols. We are taking up one more reaction that will again be a distinguishing test. That will be the last reaction for today. Next property number 5. Victor Meyer's VICTORMEYER. Victor Meyer's test for primary, secondary, and tertiary alcohols. For primary, secondary, and tertiary alcohols. Given alcohol is reacted with iodine in the presence of red phosphorus, and then with AgNO2, silver nitrite. Nitro product obtained is then reacted with nitrous acid. Nitrous acid is HNO2. Nitrous acid. Next paragraph. If alcohol is primary, a red product is obtained, which is soluble in aqueous NaOH. Write down equations. RCH2OH, primary alcohol. Alcohol with iodine, red phosphorus, this will lead to the formation of iodoalkane. You have studied this reaction. Plus water I have not written. This iodoalkane is then reacted with AgNO2. Even this reaction you have studied, this is NSR, nucleophilic substitution reaction, and this will lead to the formation of nitro product. Plus AgX, which I have not written. Now, last step. This nitro product is then reacted with nitrous acid. think of the structure of HNO2 like this. This oxygen and these two hydrogen atoms will be eliminated as water. Look at the structure carefully. This final product obtained is red in color, and this product is soluble in aqueous NaOH. Right? Two hydrogen atoms and one oxygen will be eliminated as water. Carbon will form a double bond with nitrogen.
Will it be NO2 or NH2?
Where? This
So
sorry,
you have written
NO2.
NH2.
Yes, NO2. Please correct it. That was for primary alcohol. Further write down. If the alcohol is secondary, a blue product is formed, which is insoluble in aqueous NaOH. Insoluble in aqueous NaOH. Now I'll write equations for secondary alcohol. There'll be slight change. I'll slowly keep on making changes so that you can easily understand, and you'll find there's not much difference. Replace one hydrogen by alkyl. This is secondary alcohol. Please keep on writing the equation. Make the same change in this product. Next. Make the same change in the next product. Now this product is now reacted with HNO2. OH from HNO2 and hydrogen from here will be eliminated as water. This product is blue in color, and this is insoluble in aqueous NaOH. Further item, if the alcohol is tertiary, nitro product does not react with HNO2. That is, last product means nitro product is colorless. Now for equations, look here. Replace this hydrogen by alkyl. This is tertiary alcohol. Replace by alkyl. Now this nitro product will not react with HNO2 because there is no hydrogen attached to this carbon atom. So no reaction with HNO2. No reaction. This is called Victor-Meyer's test for primary, secondary, tertiary alcohols. In case of primary, we get red product. In case of secondary alcohol, we get blue product. In case of tertiary alcohol, the last product is nitro, which is colorless product. Right. That's all for today.
Thank you, sir. Bye, sir.
Bye.
Thank you,
Bye.
sir.